Welcome to Science Snippets. I'm your host, Mr. Leibner, here with my co-host,
Mrs. Ansel. We love Earth science, and we're here to talk about some current events in the field.
So buckle up and get ready to blast off, because Earth science rocks!
In this episode, we talk about the James Webb Space Telescope and Perseverance Rover on Mars.
Hey, Mrs. Ansel, how you doing?
I'm good. How you doing,
I'm
turd?
doing okay. So something you guys don't know. Something you guys don't know is Mrs. Ansel gets a little nervous about this. And so I've been giving her a really hard time. But the stakes are low. It's okay. Tell me about the article you picked for this episode.
All right. So I read an article about the James Webb Space Telescope. It talked about basically it completed its voyage to French Guiana, where it's going to go to the launch site to be launched later on. It was written by Richard Speed, and it was in the Register. So NASA's James Webb Space Telescope recently took a 16-day journey from California. It went through the Panama Canal for a total of a 5,100-mile voyage to this place where it's going to be launched from. So that was a big deal. It's scheduled to be launched on December 18th, and it is going to launch on an Ariane 5 rocket. So one thing I was surprised about is that work originally started on the James Webb Telescope in 1996, and the original launch date was 2007, which is crazy.
Oh, wow.
In the past, based on what we are now. And their original budget was going to be about $500 million. They're up to $10 billion for this telescope now.
Oh, man.
So huge increase in both time and expenses for this telescope. However, it's supposed to really change everything in which we can see as far as the universe goes. So there's some big differences. They've compared it a lot to the Hubble Space Telescope in the article. So big differences between the two. One is the orbits are different. Hubble orbits the Earth, follows the Earth's orbit around. So one benefit to that is that a lot of times we can go make adjustments to it or fix it if something were to happen. Where the James Webb is going to be in the Earth-Sun L2 Lagrange point, which is a whole new orbit that we haven't really launched much in. But the great benefit is this allows us to see things we normally couldn't, but there's a lot of problems that come with that. For example, there's this really large sunscreen that they have to put on it to protect it from the heat and keep it cool in order to get the information that it needs in those observations. But the unfolding of that sunscreen when it gets there is supposed to be this huge endeavor, this really new technology, sort of similar to when they launched the rover on Mars and that launching of it. So that's been a really challenging for the scientists involved.
So can I pause you for a second?
Yeah, go for it.
So back up to the voyage. So this thing went from California, obviously by boat,
Yes.
all the way through the Panama Canal,
Yes.
over to Europe where it's going to be launched.
I think it's in South America.
Oh, I'm sorry. Where'd you say it was?
French Guiana, but
French Guiana. Okay.
Yeah.
Okay. So this piece of technology that was supposed to cost $500 million
Yep.
and ended up costing $10 billion. Did they say anything about how the budget increased? Was that part of the plan? Like as they were doing it, they were like, hey, let's attach this, or was it over budget? Do you have any idea?
So I think it didn't go into many specifics. It did say, like, the overall construction of this was done in 2016.
So it's been done for a couple years. Okay.
However, they've been doing a lot of testing on it.
Okay.
And these testing, and one of the tests, it resulted in a tear in this huge sunscreen.
Okay.
That's a huge money thing. So they've run into a lot of difficulties. Also, with where it's orbiting, they're running into a lot of problems trying to make sure that it will be able to stay there as long as possible and deal with the adversities that come with being in this orbit. So I think this is just sort of a new thing. They've run into a lot more obstacles and challenges than they anticipated.
So it's still going to orbit the Earth, right?
So I was looking at it, the L2 orbit.
Yeah, I don't know what that means.
It is, looks like there was like 4 of them, but that's sort of extended beyond Earth. I looked up a picture. I don't really understand it, to be honest with you.
Okay.
But
I'm not familiar with it. I'm not sure.
So it's something that I would have to research further. But it will not.
So it'll be further away than Hubble is now.
It is not likely that scientists or astronomers will be able to get back to it in order to fix something that were to go wrong on it.
Oh, interesting.
And that's the big thing. So once it's launched, it's sort of out there. It's going to take 30 days for it just to get within the orbit, and another 6 months for it to pretty much commission everything that it needs to in order to set up. So you're looking at 6 months plus 30 days from launch. So over half a year before it's really in orbit, ready to go. And then they're thinking it'll last about 5 years once it's there, and that is it.
Oh, wow.
But if they were to try to get astronauts there, that would be a whole feat in itself, because we've never tried that before.
Okay, all right. So this is a pretty limited lifespan event too. That's interesting. Do they already know what they want to look at? Do you have any idea about that?
So one of the cool things is it runs on these wavelengths that are completely different than other telescopes that we look at. Okay. It's a lower frequency wavelength. And what that does, allows us to observe objects that are much older and much further away than we've ever been able to observe before.
That's really neat.
Yeah. So they're looking at, we're going to be able to see so far back in time, but these old things we've never been able to do before. That'll be completely new. So we'll be able to see things we haven't seen before.
Oh, that's super cool.
Yeah.
So that's one of the troubles that we have with the telescopes here on the planet, and even things like Sophia. That's why Hubble is so neat, is because it gets beyond all of the water in the atmosphere, and so it can see things when you're in orbit that you can't see from our planet here because of atmospheric interference. It's kind of like how the stars get blotted out by the sun at day, right? They don't go anywhere, but you can't see them because of visibility. The same thing happens with things along the infrared spectrum or along the electromagnetic spectrum, because there's all these molecules in our atmosphere that we can't see through. And so that's why infrared astronomy has taken off so much, is because it allows you to see through a lot of those things, particularly the further away you get from the ground. So it'll be really neat to see this stuff without any of that interference at all. Mm-hmm. I mean, those should be some pretty awesome photos.
Yeah, it really should be. They had Thomas Zurbuchen, an associate administrator for NASA's Science Mission Directorate in Washington, D.C., said, "We're going to see things in the universe beyond what we can even imagine today."
That's super cool.
Those are strong words.
Yeah, that's really neat.
They're hoping to see things they can't even imagine in the first place.
So maybe you already said this, but I missed it. So the lifespan of this is only about 5 years.
Yes.
Is it because the orbit is going to change through that time and we're going to lose track of it physically? Or is it because there's instrumentation on it that's going to wear out, power, or?
It's a good question. The biggest limiting factor for that will be fuel.
Okay.
And keeping it in that L2 orbit
will
require fuel, and since they won't be able to refuel it where it's at, that is the limiting factor for the 5 years.
Okay, cool. That's super neat. That's super neat. That's a lot of fun. Anything else you wanted to mention, or?
Nope, that's it. So
that's cool. So $10 billion in
5 years,
several years beyond.
Well,
beyond its
they finished in 2016. That's a long time.
It's a long test
to launch.
Yeah, that's a long test. So if people started working on this in the 90s, I mean, people have done their whole career on this.
Oh yeah.
So these projects are huge, and we kind of talked about that in the last episode.
We did.
These space projects are absolutely massive and go for decades.
Yeah.
So somebody could be able to begin and finish their career with this particular instrument.
Yeah, and I'm really hoping, going back to our last podcast too, that they make this more aware to the public, so that they can see these neat images and make the public invested. Yeah,
that'd be super neat.
Yeah.
Oh, cool. Well, thanks for sharing.
Yeah, for sure. So what did you read?
The one that I came across is a recent article on some of the exploration that we have going on Mars. So the Perseverance is one of the rovers that NASA has put on Mars that they're currently using for quite a bit. But the thing that caught my attention about this was the audio recordings that they're doing with it. So there's not a whole lot on Mars, right? Okay. There's not vegetation. There's no animals running around that we've discovered. There's no people out there. It's literally a planet inhabited just by robots, right?
Right.
So the things that you can hear are things that you would be able to hear in a desolate landscape. So wind, the robots themselves moving around, and that's what it's recording. So it's got these two mics on it. I'll link the article in the thing for both of these, in the description of this podcast. So anybody that wants to look at pictures or check out the articles themselves can do that. But the rover has a boom arm that's going up vertically, and one of the microphones is there. So that one's in a really good place to get wind or kind of directionally point where they want to record something. The other microphone is down on the side of the thing, kind of like being on the driver's side door of your car.
Okay.
Okay. So as it's going along, it can only get sound in one direction or sound that comes around that way. One of the neat things about this is the importance of field work, not just theory. So the Martian atmosphere is quite a bit less dense than our atmosphere. So the scientists were saying, as they were preparing this and they were theorizing about how recording sound would work, is that sound will be different on Mars than it is here.
Okay.
So things that you hear here would sound differently on Mars because the atmosphere through which the sound wave is carried is different. So they were saying that you wouldn't be able to hear as far as you actually can. And so that's awesome because now they're finding out, not that their theories were wrong, but it's time for them to be updated. You can hear from quite a bit further distance than they thought you could. It's also a real bass-heavy environment. So because of the way the atmosphere is, or the density of the atmosphere, it doesn't carry high-frequency sounds very well. So most of the low stuff comes through pretty well. And the things that they're picking up are wind gusts, the wheels rolling over the terrain itself. And these wheels on the rover are metal.
Okay.
So imagine a metal wheel scraping across a rock, and that's what you hear. Yep, they're going to be noisy. And one of the cooler things I thought that they picked up was the Perseverance has a helicopter associated with it, like a little drone, a little buddy that it goes with, and it was able to capture the sound of that thing flying, which is pretty cool. And again, it's pretty bass heavy. There's a link here in this article to a video that NASA produced talking about this and sharing a couple of those recordings, but there's also a link to the full-length recordings, or some of the full-length recordings. So it's kind of fun to hear. To us, it sounds almost kind of like an ambient noise windscape or something like that. So it's hard for us without a whole lot of context to pick up what's going on in this, but it's certainly interesting and neat. Another thing that was really neat about what they had recorded, one of the ways they're doing geological studies is they're pointing the laser on the top of the boom at rocks, and they're essentially burning holes in the rocks, and then there's a vapor that will come off as the rock is burning or as the laser's cutting holes in it, and they're analyzing that vapor, and they were able to capture an audio recording of that happening. And so that's pretty neat too. I thought it was some pretty cool stuff going on with that.
So they're thinking that being base heavy is due to the less dense atmosphere then? Yeah.
So those higher frequencies, you can hear like the high pitched whine of the electric motors and things like that as it's going. Like that's available there, but it's just harder to transfer those kinds of things through a less dense atmosphere.
So are they constantly taking audio data, or is it just an off and on kind of thing? Did it say?
No, it's an off and on kind of thing. They have to tell it to do it. And that was one of the things that they discussed in this. It would be nice to go ahead and get more and more of this data so that they can check it for maintenance. So just like a mechanic, that was the example that they used, would listen to your car, right? Or the doctor listens to your lungs. They would be able to listen to the rover itself and compare it with sounds that they know, or over a larger data set, compare it against its own recordings to see if things have changed. And so they can listen for essentially flags for maintenance. Yeah.
I wonder what their general goal is, or what they hope to gather from this sound data.
A lot of it has to do with atmospheric knowledge gain. They want to know more about the atmosphere, more about how sound works in the atmosphere, more about what you would be able to hear when we get to the planet and how we can communicate that way. Primarily, it's just general data collection.
Okay.
Mm-hmm.
That's interesting.
Yeah, pretty neat. It would not be probably something you would put on like your top 10 lists for your workout soundtracks.
It's not quite upbeat enough?
No. But it is something that you would probably want to fall asleep to. So it's kind of fun. Yeah.
Yeah.
So there's a use for it. The final thing I thought was interesting is these microphones are generally available to the public. Like these are microphones you can go onto Amazon and order. So not that necessarily you need to do that, but if you desire to, you certainly could.
Very interesting.
Yeah.
Thanks for sharing.
Yeah, thanks. So we will link both of these articles in the description here, and hope that you have an opportunity to look at them and enjoy them. Thanks.
Thank you. Thanks for listening to Science Snippets. If you like this podcast, feel free to subscribe.
If you didn't like this podcast, you're wrong. If there's an article you're interested in hearing us discuss, please leave a comment.
Thanks, friends. And until next time.